All right, reference angles have been defined, and it is typical if you are struggling a little bit with figuring out how to calculate one, how to find one. So let's do one to warm up here. Here's an example. Let's find alpha, which is going to be my code for a reference angle, if theta is equal to negative 475 degrees. This is tricky. How are we going to figure out what alpha is? I wrote a step-by-step guide in the last video, and step one was to draw it. So let's draw this thing. To do it, we're going to have to take our time on this. Negative 475 isn't that easy to draw. Remember that it is negative, so it's starting at the initial ray, and it's going this way, negative. 90, 180, 270, 360, 450 is back down here. It's another 25 in this way. So there is negative 475, and we should probably have our arrow there. So there's negative 475. Now my step two was locate the reference angle, alpha. And the reference angle alpha, very important, it's always the same. It's the acute angle, acute means less than 90, that's formed between the terminal ray and the x-axis. Now the x-axis points in two directions. It points in this direction, it also points in this direction. There are kind of two angles here, actually. There are exactly two angles that are formed between this and these two rays. You could think of this little angle or this one, but it's the acute one that is the reference angle. It's the acute one. It's this one. It's the one that's less than 90. That is alpha. So that's step two, just locating it. The third one is to use geometry and your knowledge of how these numbers work to figure out what that angle is. Now this is going to be something you're going to have to work out for yourself. There isn't one way to do this. There's a bunch of ways to do this. My way right now is going to be to do this. I'm going to think about how I calculated this rotation by going negative 90, 180, 270, 360, 450. This is negative 450 right here, pointing this way. Negative 475 would be another 25 units. Notice I'm not writing a negative here anymore because I don't care about positive, negative. But this is another 25 degrees. I want to know what this one is. Now, this whole thing is 90. So just geometrically, I can see that if I take 90 minus that 25, I get alpha, which is going to be 65. And if you feel like that was not a very algorithmic process, like what's the rule? How do I do it? There isn't one. You have to think about the geometry and just see the diagram. Draw it. So that's the answer. It's 65 degrees. There isn't a formula. I promise you, there is no formula that will get you that 65-degree angle from this that's one that you can memorize and it'll work every time. Because it just depends on which quadrant it lands in. So don't expect there to be a formula. You have to do the geometry. And so we end up with alpha is equal to 65 degrees. Notice it is not negative. You might think, wait, were we doing negative numbers? No. The reference angle is always, always, always a positive acute angle. It's not in standard position. That's how you do it. Let's do one more in radians just to practice one more time. So let's say that we want to find alpha as a second example. If theta is equal to, I don't know, let's say it's 7 pi over 6. 7 pi over 6. Draw it. Notice the first step is not change it into degrees. I know that some people want to change this into degrees, and if you want to do it, you can go ahead. But I want to say to you, you're actually setting yourself back if you start, as you're practicing, by having to change this into degrees. It's like being a language student and learning Spanish. If you're always translating everything into English everywhere, then you're never going to actually learn Spanish. You've got to learn to think in Spanish. In this, you've got to learn to think in radians. So I'm going to think about 7 pi over 6. Now remember, pi means a half term. Pi is a half term. 7/6 of pi is what we're talking about. 7/6 is more than 1. It's 1 plus 1/6. It's 6/6 plus 1/6. So that is 1/6 of pi more than a half turn. So that tells me that I'm in the second quadrant And this little extra bit is 1 pi over 6 bigger. And here's the beautiful thing about that way of thinking. That's actually the reference angle. That's alpha, because that is the acute angle that's formed between the x-axis and the terminal ray. And that's the answer. Don't think about that. You should be able to do that on your own in that way eventually. So if you're not there yet, practice. That's alpha for that one. Okay, so those are important skills, or that is an important skill to actually find the reference angle. But here is one use of reference angles, is to use special angles of 45 and 30, etc. Here's an example. We're going to use reference angles. It's my shorthand for reference angles. It's my angle symbol. And our memorized unit circle picture. Not a calculator. To find the value of, let's say, the cosine of, let's say, what are we going to do? How about 135 degrees? So we want the cosine of 135. We're not going to use a calculator. What we're going to do instead is we're going to draw it. That's the first thing that you want to do, is you want to draw it. 135 degrees is 90 plus another 45, gets us halfway through the second quadrant. There's 135. So, step one, draw it. Step two is to figure out what the reference angle is. Find what we're going to call alpha. Now, if you look carefully here, you have to find alpha, there were steps. And the steps for finding alpha were, first, after we draw it, we have to figure out physically where is alpha. Physically, it's this angle. There's the acute angle formed between the x-axis and the terminal ray of theta. There it is. And we just have to use a little geometric intuition to see how much that is. 180 is this whole thing, so we need to add 45 to that to get to 180. Oh, this is 45. You need to use a calculator on that. 180 minus 135, okay. But learn to do this, get better at it. So that's alpha. Step three is we now know that we can find, we know now that the cosine of 135 is equal to the cosine of the reference angle or the negative cosine of the reference angle. It's one of those. That's what the lesson from the last, that's what the last lesson was about. It was about really realizing that when we find the reference angle for something, we realize that, oh, the cosines and sines and tangents, they're always the same number of the reference angle as the original angle, or they're the opposite. Now the thing is, we know what the cosine of 45 is. Cosine of 45 is on that memorized diagram. I'm not going to redraw it, but the ordered pair, you should have it in front of you, hopefully. The ordered pair for that 45-degree angle is root 2 over 2, comma root 2 over 2. I want the x value, I know they're the same, but it's the x value because it's cosine. And so it's root 2 over 2. So now the question is, all right, so the cosine of 135 is equal to root 2 over 2, or is it negative? Which one? How do you judge? How do you know? It's in the picture. You can tell in the picture. You're talking about the cosine of this angle of 135. And it's the x value of this point. The question is the x value going to be positive or negative over here? This is a visualization. If somebody has taught you an acronym of, or a mnemonic of all students take calculus or something, forget it. It's a bad acronym because it causes you to not understand something deeply that will be helpful. The reason that this one is going to be a negative value is that the x value is negative. X value at that point is negative. It's negative because we're in the second quadrant, because the x value is negative. And that, and that is how to solve that problem. You're going to have a bunch of them, I predict, that are just like this. You're going to be asked, find the sine of 5 pi over 3, find the cosine of pi, find the tangent of 7 pi over 6. And it's going to turn out all the angles I just said, I know I said them fast, all of them have reference angles that are either 30 or 45 or 60. Or they are landing on a quadrant, like 90 or 180. And you should be able to find every single sine and cosine value because you know the ordered pairs that I've asked you to memorize. All right. Hope that's helpful. Practice these. Do lots of them. And if you're not getting them right, figure out why, and then practice them again until you can do them. And you'll do really well.